If a particle was projected from the origin O on a horizontal ground with initial velocity 17I plus 11j meters per second, write its position vector at time t seconds. Consider the acceleration due to gravity to be 9.8 meters per square second. We're given the initial velocity of the particle in a vector form. Its horizontal component is 17 meters per second and its vertical component is 11 meters per second. We want to find its position vector, let's call that s, at time t seconds. And so we're going to use one of the equations of constant acceleration. We're going to use the equation s equals ut plus a half at squared. Now we can convert this into vector form. We can say that s, u and a are vectors. Let's substitute what we know about our particle into this formula. S is equal to u times t, and we know that u is 17I plus 11j. And then we have a half at squared. Now acceleration in the horizontal direction is 0, but in the vertical direction it acts against the direction of the original velocity. So it's negative 9.8. And so we find that s is equal to 17I plus 11j t plus a half times 0I minus 9.8j t squared. Let's distribute each of these set of parentheses, and we get s equals 17ti plus 11tj minus 4.9jt squared. And we now gather the vertical components. And that gives us s equals 17ti plus 11t minus 4.9t squared j. This is measured in meters. And so we're done. We've found a position vector at time t seconds. It's s equals 17ti plus 11t minus 4.9t squared j meters.